Hey everyone, in this video I'm going to talk about an exorcism example that I've already completed, so you won't see the whole process, probably the whole miserable process of me trying to solve it, but you will hear me talk through the result that I came up with, and I'll point out some community solutions that I think were interesting and at least a different take on the problem. So this problem is one of the first three, I think it's the third in the Python track, called Raindrops. And at first it seemed kind of crazy, which I guess a lot of these exercises are pretty contrived. But after reading it a couple of times, I understood the problem. So the goal is to input a number, or you'll get a number calling a function, and you're supposed to convert that number to a string based on certain criteria. And if you can't meet those criteria, if the number doesn't meet those criteria, then you do something different. Basically, the rules are here. If the number that is input to the function has a factor of 3, and only 3, the result that you should output, the result that you should return is just a string that says pling. If the number has a factor of 5 and only 5, the answer should, the result should be plang, a string that says plang. And if the answer has a factor of 7 and only 7, the return string should be plong. But if it's any combination of these, if it has a factor of 3 and 7, it should be pling plong as one string. If it has a factor of 3 and 5, it should be pling plang. If it's a factor of 5 and 7, it should be plang plong, etc. If the number isn't divisible by 3, 5, and 7, then you should just return the digits of the number. And I think you should return them, you should return them as a string. This was an important detail that kind of tripped me up. And maybe it was because I didn't read the problem as well as I should have, or maybe it was my methodology that caused me to have to figure out an extra step. But I'll talk about the steps here. First, I'll show you that PyTest passes. So everything passed in 100%. And there are actually 18 tests that it runs. So it's pretty comprehensive what they've built in the exorcism module. So let's dive into what this does. The name of the function is called convert, and it takes one argument or one parameter called number. I chose to create a string, a blank string at the very beginning, and this is where I'm going to be building my string of pling, plang, plong, pling, plong, or whatever. And then I created another variable that starts out false, and that variable is called factor. The reason I called it factor was because I want to turn that variable to true. I want to use it as a signal to say that whatever number I just processed was a factor of 3, 5, or 7. So if it's a factor of 3, that gets checked in this first conditional statement. So we're referencing number here. We're taking the number that is a parameter in our function and using the percent sign to do a modular division operation. I don't really know why it's called modular division, but what it means is that we're going to do a division like 9 divided by 3, but instead of having the result of 9 divided by 3, which would be 3, we're going to take the remainder. So if we remember back to our long division days, the remainder is what's left over anytime we divide something that isn't perfectly divisible. So 9 divided by 3 is perfectly divisible. The answer is 3. and the remainder equals 0. But 10 divided by 3 is not perfectly divisible, and there's going to be a remainder. So the remainder will be non-zero. I can't tell you what it is off the top of my head, but that's what calculators are for. So this conditional statement says if number modular divided by 3 is 0, that means we're going to only test if the remainder is 0. If the remainder is 0, then we're going to go into this part of the program, and we're going to set the blank string that we created at the top equal to pling, and we're also going to set the Boolean, the true-false number that we called, the true-false variable that we called factor equal to true, because we said, yep, this was a factor. This was at least divisible by 3 with no remainder. And then we go on to the second conditional statement, and that's related to the number 5. So we're checking to see if 5 is a factor. So if the number that gets called with the function is 15, it's going to pass this conditional statement because 15 is divisible by 3 with 0 remainder, and raindrops will be set equal to pling. Factor will be set equal to true. And then we're going to go to this next conditional statement, and we're going to check and see if number, which is 15 still, modular divided by 5 is remainder 0, and 15 divided by 5 is remainder 0. Then we're going to take raindrops, and then we're going to set it equal to itself plus plang. So this is appending or concatenating the second word onto pling or blank, depending on what the number was. If number is 5, we wouldn't pass this test, and raindrops would never be set to pling. So if number was 5, we would skip these 2 lines and go straight into this line, because 5 mod 5 is remainder 0. So we would have raindrops equal to blank, because we would still have the initial value of raindrops, plus plang. So at that point, if number was 5, raindrops would just be plang. But if number was 15, it would be pling plang. So that's the same process for this conditional statement divided by 7. The only difference here is that we're appending plong. And you'll notice that factor gets changed to true in all conditional statements. So if one of these is true, factor is going to be true. And that's important for the last conditional statement, where we're checking that if factor is not true, that is to say, if it wasn't divisible evenly by either 3, 5, or 7, then return a string that contains the number, the original number. So that's what this last clause is in the instructions. If it does not have any factors, 3, 5, or 7, the result should be the digits of the number, but in the format of a string. And that's what I missed early on. So I'll go ahead and say that the sticking point for me was I just returned number here. And if we run PyTest now, first let me save that. If we run PyTest the way that is, it's going to error because in this case, 52, the number, is not equal to 52 as a string. Strings always have those quotes around them. So using this function, str, allows me to, I like to use the word coerce. I'm taking an integer or a floating point number and I'm making it into a string. I'm forcing it to be a string, even though it's stored as an integer or a floating point number or whatever. So this was critical for me to get it to actually pass the test. So I'll save it again and show you that the tests pass when that string str function is in place. And if factor is true, so if we entered into one of these conditional statements and factor was equal to true, then we don't enter this conditional statement, because if factor, this is kind of confusing, I'll admit. What we're saying here is if not true. So if this is not true, then go here. So if this is true, then we skip this line and we go straight to the else statement. So this is not is like a negative sign. So we're looking for this to be positive, so to speak. And if factor is true, negative truth is false. I may be making that even more confusing, but suffice it to say that this does work, and this if-else statement is allowing me to differentiate between numbers that were factorable evenly or divisible without a remainder by 3, 5, or 7, and the numbers that are not divisible by 3, 5, and 7. So if that number was not divisible, it returns a string of the number that was originally input. If it was divisible, so if factor is true, this statement is false, because not is taking the opposite of whatever the truth, whatever the value is of factor. And it goes here where it returns the string. So whatever I built up with the strings pling, plang, and plong. So that's a really in-depth look at what I did. Let me pull up a community solution, some of the recent ones. And it's just another one in the list here. So this is the same function definition. Here they're setting up, let me make this step bigger. So we're starting with a list called drops. Remember, we're using square brackets wherever we have a list. And then another list that's blank called XA, and then result, which is just a blank string. If number modular divided by 3 and number modular divided by 5 and number modular divided by 7. So this is looking, is this true? And is this true? And is this true? Return string number. So yeah, so if the remainder is not 0 for each of these, those will count as true, I guess. Then, so this is effectively the last, returning the same result as my last clause here. So he's checking, this person is checking right at the beginning whether or not you've got a number, which is probably a smart thing to do. And then if number mod 3, so this is the same clause that I have here. If number mod 3 is equal to 0, xa append 0, xa append 0. Man, that's interesting. So I understand. I'm a little bit curious if this works, because I understand that you can append to XA, but what are you appending? Let's see. I'm gonna save this as Raindrops. I think his name was noob123. .py. I think PyTest. Whoops. PyTest. Raindrops. Noob123. I think I can do that and test. No, maybe not. Okay, we can test this step by step here. I'm gonna build this. And we've got drops is a list now, and XA is a blank list. And so XA should be, yep. Now, I'm curious what happens when we do XA append 0. What is XA? Yeah. Okay, that's obvious to me now. Had to prove it to myself to see it. Now, how does he get the result here? So for I and XA. Okay. Oh, wow. So he's building up a table. Not a table, I'm sorry. He's building up a list that maps to drops. But then he has this extra for loop which builds the string based on that mapping list. Ooh, wow. That seems harder to me than what I did, but naturally it would because I didn't do it. But yeah, like, it's a good use of lists for sure. And I'm trying to think how this could be. So one way this would be a lot better is if these words needed to change, this would be a much easier instruction to modify than mine. Because mine, you've got to go modify 3 different lines. If you could imagine this was something a lot more complicated than it actually is, it would be much easier to be able to modify one list that has all of those words in it instead of keywords spread all the way out through the code. So this is definitely a good idea from that perspective. If you wanted to replace these words with something else, zing, zang, zong, whatever. Another reason that it would be useful to do it this way is if this list of words was actually coming from another place. So if you had, if you were passing in a list as another attribute, and drops was coming from another function, you would need to map to the position in that list. So yeah, it's a good idea. It's I think ultimately a more robust way of working. If you're thinking about this code being reused in different applications, so that's interesting. Go back and look at another one here. Just the next one in the list. Okay, so this one looks also, very different as well. I'm going to go ahead and copy this one and save it here. This person's name is YYY. And they're starting with, okay, they're just going ahead and doing that modular division for every factor right off the bat and storing it in these variables A, B, and C. And then creating a blank variable called string. And then they use a conditional statement that says if, so again, this is going to be if a remainder exists for every factor, 3, 5, and 7, then it's not divisible evenly by any of the factors, so we just need to return the number. And this person had to use the string str function too to coerce that number to the string format. So I don't remember if, okay, noob123 did as well. I guess that's true for most solutions based on what I've seen. But then this person is actually kind of going the same route that I did, where you have pling, plang, and plong in each one of these conditional statements, and you're testing to see if the remainder was 0 for A, which is number modular divided by 3, it gets pling. If it was remainder 0 for B, which is modular divided by 5, the result is plang. And if the remainder for C, which is number modular divided by 7, is 0, then he adds on plong, and he just returns that. So this one, I feel like if I had to compare the 3 that we've looked at, is a lot closer to what my solution was. But still a different approach. And it's interesting because he's taking all of that calculation and doing it right at the top. And this person's also taking advantage of the Boolean value of that modular division. So if the remainder is non-zero, then that shows up as true in this conditional statement. So if there's a remainder for A, B, and C, this would evaluate to true, and we would know that that the number is not a factor of 3, 5, or 7. So noob123 used it here in this format. So it's interesting to see how other people solve these problems, and it's fun to be able to learn from those. They make a good point on the Exorcism website about how you can learn a lot from looking at somebody else's code, and it helps you to build out your repertoire, or build out your vocabulary, so to speak, of possible ways to solve a problem, because there's a lot of different ways to approach even a very simple problem. And unless you look at it in somebody else's code, you might not be able to see those on your own.